Hi, good morning. My name is K.Purushotham. I am working as a assistant professor in the Department of Electronics and Communication Engineering from MLRIT Institute of Technology. So today I am going to give the introduction to the analog and digital communication system. So the first top topic what I am going to discuss is introduction to the communication system. Introduction to the communication system. So in the introduction to the communication system, it is containing three blocks: information source, transmitter, channel, receiver. So first block is nothing but information source. The information source, what it is containing? Basically, before discussing the information source, we are discussing about the signal. Signal, how it is defined? Signal is a function of one or more independent variables which contains some information. Signal is function of one or more independent variable and which contains information. If signal is containing the information, it is having the characteristics of the signal. The signal characteristics of the signals are first one is amplitude. Second one is frequency. Third one is phase. First one is amplitude, second one is frequency, third one is phase. What is the amplitude? Amplitude is nothing but the strength of the signal. Amplitude is nothing but strength of the signal. Amplitude is nothing but strength of the signal. So if my signal amplitude is very less, means the strength of the signal is very low. So I am not able to cover for the longer distance. Means if I am taking the class in the classroom, if I am speaking slowly and my signal strength what I am delivering is very less, so last bench students are not able to catch my voice. So for that what I am doing, I am increasing the strength, I am increasing my voice. So that is nothing but strengthening the signal is known as amplitude strengthening. That is nothing but boosting the signal or increasing the strength of the signal. Is next to frequency. If my signal is containing some information, that information is nothing but group of frequencies. First to the signal which contains some information, which is the function of one or more independent variable and which contains the information, is having the frequency range from 20 Hz to 5 kHz. This is for voice signal. Generally, the audio range is lying from 20 Hz to 20 kHz. This is for audio range. So, if information is containing, information can be represented some useful information, which is nothing but some group of frequencies. So, single frequency does not have any information. The group of frequencies are having the information. So, that information is nothing but group of frequency. So, frequency is the one of the characteristic of the signal. Next to phase. Phase is nothing but where the signal is starting. Where the signal is starting. That is whether theta is equal to 0 or theta is equal to 90 or theta is equal to 180. Where the signal getting started is known as the phase of the signal. So it is indirectly represented as the delay of the signal. So if some information is there, that information should have three characteristics. It should have the amplitude, it should have the frequency, it should have the phase. And information can be the any form. It may be in the text form, it may be in the audio form, it may be in the video form, it may be in the image form. So in an analog and digital communication system, we are concentrating on the information which contain the audio signal. So the audio signal only we are concentrating. Among the audio signal only we are transmitting the voice signal. Voice signal frequency is lying from 20 Hz to 5 kHz. Generally the pitch is occurring at 3.1 kHz. Pitch is occurring at 3.1 kHz. So the whatever the information we are delivering, that information is lying within the frequency range of 20 Hz to 3.5 kHz. So whatever the information we would like to transmit by means of communication is containing the frequency within the range of 20 Hz to 3.5 kHz only. What do you mean by pitch? Pitch is nothing but different persons are having the different pitch. Based on the pitch only we can identify the voice belongs to a particular person, whether it is the kid voice or female voice or male voice. Depending on the pitch only we are identifying. Next to transmitter. First we are having the information. That information is in the form of if acoustic signal is there. That acoustic signal what we are doing, we are converting into the electrical signal by using the transducer. So that electrical signal representation, after representing the mathematically and after generating the signal, that signal we are applying to the transmitter. What do you mean by transmitter? Transmitter is nothing but it is the group of components which are connected together and designed such a way that which will convert the electrical signal into the electromagnetic waves. So in the transmitter section, what it is containing? Antenna it is containing. So the antenna what it is doing? It is converting the electrical signal into the electromagnetic waves. And the information what we want to transmit, that should be converted into the electromagnetic waves, and that is transmitted in the form of electromagnetic waves through the channel. Transmitted, transmitter, transmitting the information, transmitter, transmitting the information, transmit the information in the form of information in the form of EM waves. The information is transmitted in the form of electromagnetic waves. Those electromagnetic waves are transmitted in the free space. They are transmitted in free space. Transmitted in the free space. Free space is the channel. Free space is the channel. So once we are transmitting the information through the channel, so there is the possibility of the noise. So the noise can interfere with the original information signal. So once it is interfering with the original information signal, there is a possibility of distortion. So the information what we are transmitting, that information is containing the original information and noise is also there. So the noise plus information we are transmitting through the free space is the channel we are taking, and at the receiver, next section is nothing but channel, after that receiver. So receiver section, receiver receiving the signal, in the form of EM waves, in the form of EM waves. And receiver is also containing the antenna. So what it is doing? It is converting the electromagnetic waves into the electrical signal. So electrical signal is containing the both information is there and noise is there. So in the receiver section, what we are using? Low pass filter we are using. So low pass filter, what it is doing? It is removing the noise content and extracting the original information what we have transmitted from the transmitter section. So throughout the block diagram of the communication system, first information we are generating, that information we are converting into the electrical representation. After representing the electrical signal, we are applying to that one transmitter. Transmitter is containing the antenna. Antenna is converting the electrical signal into the electromagnetic waves. Those electromagnetic waves we are transmitting through the channel. Channel we are taking as the free space. So through the free space, we are transmitting the electromagnetic waves. So once we are transmitting the information through the free space in the form of electromagnetic waves, there is a possibility of the noise. So noise can enter at any time. It can be generated in the transmitter section. It can be generated in the receiver section. It can be generated in the channel section. So the noise is added to the transmitted signal. And finally, in the receiver, we are converting the receiver we are converting electromagnetic waves into the electrical signal. So the electrical signal is again processed. Processing is nothing but changing the characteristics of the signal. So what characteristics we have to change? If the strength of the signal is less, we have to amplify that signal. If any distortion is there in the frequency, equalization, and we have to remove the distortion in the signal. So low pass filters and signal processing algorithms we are using at the receiver side to reconstruct the original information from the received signal. So this is the overview of the block diagram of the communication system. So next, here we are using the modulation technique for the transmission of the information. Modulation is the process of changing the parameters of the signal. Parameters means are characteristics of the signals. The characteristics are amplitude, phase and frequency. If amplitude of the carrier is changing according to the instantaneous values of the message signal, we are calling it as a amplitude modulation. If the frequency of the carrier is changing according to the instantaneous values of the modulating signal, we are calling it as a frequency modulation. If the phase of the carrier is changing according to the instantaneous values of the message signal, we are calling it as a phase modulation. So in instantaneous values of the modulating signal, what is the meaning of instantaneous values? So their modulating signal or information signal or baseband signal which contains the information is not a constant. It is time varying signal. So it is varying at particular instant of the time, some value is there, another instant of the time, another value should be there. It is the group of the frequencies. It is the more the randomness, more the information content in the signal. So that's why the instantaneous values of the information is a not constant. It is time varying signal. That's why according to the information or instantaneous values of the information, carrier characteristics we are changing. That we are calling it as a modulation. So what is the need for the modulation? So can't we transmit the information without modulation? If you transmit the information without modulation, what will happen? So if I would like to transmit the information without modulation, that signal cannot be transmitted for the longer distance. So if I am transmitting the signal for the longer distance, the signal strength is going on decaying as it traveling for the longer distance. So that's why we are using the modulation. One reason. Second reason, if the signal is interfered with the noise, that noise is concentrated in the low frequency, that power line noise and other noises which are generated inside the transmitter and the channel, and if noise is containing the information, so the strength of the signal is very low and noise is also there, and if you are transmitting that information for the longer distance, we are not able to recollect the original information what we are transmitting from the transmitter section. So that is also one reason. So next, based on the signals are incompatible for direct transmission for such signals to travel longer distance, its strength has to be increased by modulating with the high frequency carrier wave, which does not affect the parameters of the modulating signal. So to transmit the information, we have to use the carrier. Directly, we cannot transmit the information. If you are transmitting information directly, it will be die. It will not go for the longer distance. So for that, we are using the carrier signal. The carrier characteristics we are changing, but we are not changing the information content. Only carrier characteristics are changing according to the information. So next, what are the need for modulation? What are the reasons? What are the reasons we are using for the modulation? First, reduce the antenna height. First reason is reduce the antenna height. So antenna height h is equal to lambda by 4. H is equal to lambda by 4. Lambda is equal to c by f. C is equal to 3 into 10 power 8 meters per second. F value, if I am transmitting 5 kilohertz, so the lambda value is 3 into 10 power 8 divided by 5 into 10 power 3. So let me take 30 into 10 power 7, 5 into 10 power 3. So that value becomes 30 into 10 power 4 by 5. 6. 6 into 10 power 4, which is nothing but 60 kilometers. So what is the height? Lambda by 4. 60 by 4. That is nothing but 15 kilometers. Constructing the antenna with the height of 15 kilometers is practically impossible. So if you want to transmit the original information directly, the antenna height required is 15 kilometer. So this is practically not possible. So if I am using the modulation, so modulation, what is the frequency? Carrier frequency fc is equal to 1 megahertz I am using. 1 megahertz I am using. So what is the lambda value? Lambda is equal to 3 into 10 power 8 by 1 into 10 power 6. That is nothing but, how much you will get? 300 meters we will get. So h is equal to 300 meters by 4. 75 meters. So 75 meters antenna, practically it is possible. So physically we can construct the 75 meters antenna. We cannot construct 15 kilometers of the antenna. So this is the one of the reason why we are using the modulation. Next reason, increases the range of the communication. Increases the range of the communication. So the range of the communication means, so without modulation, we can transmit some 200 to 300 meters. Without modulation, we can transmit, without modulation, we can transmit some 300 meters only. with modulation we can transmit some hundreds of kilometers. With modulation we can transmit with hundreds of the kilometers. So high frequency signal and high power, by using the modulation we can transmit the signal for the longer distance. So this is the second reason. Increase the range of the communication means longer distance we can transmit by modulating the signal. Third one is allows multiplexing of the signal. So what do you mean by multiplexing? Multiplexing. There are a number of signals are there. A number of users are generating a number of signals. Those m number of signals are m1 of t, m2 of t, dash dash mn of t. N number of signals we can transmit by multiplexing. That multiplexing we are calling it as a frequency division multiplexing. Frequency division multiplexing. What do you mean by frequency division multiplexing? Here, different carriers for m1 of t, I am using the carrier c1 of t. For m2 of t, I am using the carrier c2 of t. For mn of t, I am using the carrier cn of t. Different carriers I am using for the modulation of different information signals. M1 of t is the one information signal, M2 of t is the one information signal, dash dash dash, Mn of t is the nth information signal. Different persons are generating the different message signals. Those message signals I am modulating with the different carrier frequencies. C1 of t, C2 of t, C1 of t is not equal to the C2 of t, not equal to the Cn of t. Okay, different carrier frequencies I am using. By using the different carrier frequencies, I am modulating the original information signal of the particular person and I am transmitting. So multiplexing is nothing but modulating with the different carrier frequencies and combining all the signals through the same channel. Same channel. Through the same channel, transmitting multiplexed signal. Multiplexed signal. Through the same channel, I am transmitting the multiplexed signal. This we are calling it as a frequency division multiplexing. So there is no question of interference. Different carrier frequencies are located at different values. So if even though the original information is lying within the frequency range of 20 Hz to 5 kHz, generally it is lying in the 3.5 kHz. That information we are modulating with the different carrier frequencies and we are transmitting through the same channel. So that we are calling it as a multiplexing. So modulation only it is possible, multiplexing of the signal. Next, avoid mixing of the signals. Avoids mixing of the signals. avoids the mixing of the signals. So what do you mean by mixing of the signals? So there n number of signals are there. N number of original information signals. N number of original information signals we can transmit through the same channel. So original information is lying in the frequency range of 20 Hz to 5 kHz. Generally, the pitch is occurring at 3.1 kHz. The n number of modulating signals are lying in the same frequency range. And carriers are different. Carrier signals are different. So, if we are mixing the signals also, there is no question of interference. And we are transmitting the n number of signals by mixing together by using the different carrier frequencies, and we are transmitting through the same channel. Next, improved reception quality. So, we are transmitting the information. Information we are transmitting for the longer distance. So, if we are using the modulation, the strength of the signal is increasing. The increased strength of the signal can be traveling for the longer distance. Even though it is traveling for the longer distance, the strength of the signal is decaying little. Okay, and at the receiver side, we are able to reconstruct the original information from the received signal. So, the receiver should have the minimum detectable signal. To operate the receiver, it required minimum detectable signal. So, by using the modulation, it is able to get the minimum detectable signal, and it will reconstruct the original signal from the transmitted signal. Okay, so the today lesson what I covered, what is the information? The information is nothing but which is function of one or more independent variable and which contains some information. That is nothing but signal. Signal which contains some information which is the function of one or more independent variable. If signal is having the information, it is having some characteristics. Those characteristics are amplitude, phase and frequency. Amplitude is nothing but represented strength of the signal. Frequency is nothing but a group of frequencies. So the voice signal, if you want to transmit, it is lying within the range of 20 Hz to 5 kHz. So generally the pitch is occurring at 3.1 kHz. Next to phase, where the signal is getting started, is known as the phase. Next we are concentrated on block diagram of the communication system. The first block contains information. The information may be in the text form, information may be in the image form, information may be in the voice form, or information may be in the some other form. So that is nothing but in the image form. So only in the analog and digital communication, we are transmitting the voice signal. The voice signal can be represented first in the form of electrical, then that is applied to the transmitter converting electrical to the electromagnetic waves. Those electromagnetic waves are transmitted through the channel. So channel, there is a possibility of noise. There is a possibility of noise which is entering into the original information signal, and it may distort to the original information signal. Finally, it is reaching to the receiver. Receiver, once again, what it is doing? It is converting the electrical signal into the electromagnetic signal into the electrical signal, and once again it is getting the electrical signal. That electrical signal again we are processing. Any noise is there, we are removing by using the low pass filtering and some signal processing algorithms we are using. Finally, we are extracting the original information what we are transmitted from the transmitter section. Okay, then we are using the modulation. Modulation is nothing but it is the process of changing the characteristics of the carrier signal according to the instantaneous values of the message signal. Next, what is the need of modulation? So, without modulation, we cannot transmit the information for the longer distance. So, by using the modulation only, we can transmit the information for the longer distance. Then, there are some parameters are there. Why we are using the modulation? First, it will reduce the height of the antenna. First thing is, it will reduce the height of the antenna. Second, increase the range of the communication. Third, allow the multiplexing of signals. Fourth, avoid the mixing of the signals. Fifth, improve the reception quality. Okay, these are the reasons we are using for the modulation.